All right, today we're going to step onto the factory floor of the future. And this isn't your grandfather's factory, all clanking machinery and grease. Nope, this one is run by intelligent, self-aware systems. We're diving into the world of advanced industrial automation and what's being called the predictive factory.
So just picture a modern factory for a second. It's this massive, complex ecosystem, right? You've got motors, sensors, robots, all working together in what's supposed to be perfect harmony. But what happens when one tiny little component starts to fail? You know, the central question for industry today isn't just about being more efficient, it's about survival. How do you stop a complete disaster before it even gets a chance to start?
Well, the solution requires a total change in mindset. For decades, maintenance was all about reacting. A machine breaks, an alarm goes off, and we scramble to fix it. But today, the whole game is different. The goal is to use data and intelligence to see what's coming down the pipe and act before that alarm ever has a reason to sound.
To really get this leap into the future, we first have to understand the foundation it's all built on. See, before a factory could learn to predict, it first had to learn how to see, feel, and react to problems in real time. This is really the starting point of our whole story.
A core tool in this foundational stage is something called fault tree analysis. Honestly, the best way to think of it is like detective work, but for machines. You start with a big failure, like say, a system overheats, and you work your way backward to map out every single possible cause, no matter how tiny. What you end up with is this incredibly detailed blueprint of everything that could possibly go wrong.
So here's how that works in practice. First, engineers use those fault trees to figure out and prioritize all the risks. Then, they work on improving the signals from the sensors, usually by combining data so they can tell if an alarm is a real problem or just a fluke. And finally, they automate the response, so fail-safes kick in or backup systems take over instantly.
You can really think of this entire reactive system as the factory's nervous system. It feels the pain of a problem and triggers an immediate reflex to protect the whole organism from any more harm. It's absolutely essential for sure, but it's still just a reaction to something that's already gone wrong.
And this is where things get truly revolutionary. We're moving beyond simple reflexes to basically giving the factory a form of consciousness, the ability to look ahead, anticipate problems, and stop them from ever happening. And the engine driving this massive leap? You guessed it, artificial intelligence.
The shift in thinking is so simple, but it is profound. On the left, you've got the old world. Fix it when it's broken. This is expensive, it causes unplanned downtime, and it's always a mad dash. But on the right, you have the new paradigm, powered by AI. Fix it before it breaks. That right there is the heart and soul of predictive maintenance.
And hey, this isn't just a cool theory. The results are measurable and absolutely dramatic. Check out this chart. It shows the error rate in predicting a component's remaining useful life. Before AI, the predictions were off by an average of over 22 hours. After deploying AI models, that error was slashed to just 9.4 hours. Now, this isn't just a number. That's the difference between scheduling a $10 part replacement during a planned break versus a $10,000 emergency shutdown. That is a huge increase in foresight.
And just how accurate are these predictions? Well, there's a metric called AUROC, and you can think of it like a report card for the AI, where 1.0 is a perfect score. After putting these AI systems in place, the score jumped to an incredible 0.94. That is near perfect prediction. And you know, it's not just one magic AI model doing all the work, it's a whole toolkit. You've got LSTM models that are like historians, analyzing data over time to predict what's next. You have CNNs that are like watchdogs, spotting weird anomalies in real time. And even transformer models, the same kind famous for language AI, can spot these super complex hidden patterns in how machines behave.
Okay, so the factory can now predict the future with some stunning accuracy. Pretty cool, right? But what's the point of seeing a problem coming if you can't do anything about it in time? And that brings us to the next critical step, building smarter, faster reflexes.
Prediction gives the factory sight, but it also needs muscle memory. It has to have the ability to act on its predictions almost instantaneously. I mean, if your nervous system senses pain, you want your reflexes to be immediate, right? It's the exact same principle here.
So, the key technology that makes these lightning-fast reflexes possible is called edge intelligence. Instead of sending enormous amounts of sensor data to some distant cloud server to be analyzed, the AI model runs right there on the factory floor, at the edge of the network. This completely cuts out the network delay, the latency, making the response pretty much instant. But of course, it's not a free lunch.
Putting that AI on the edge is a serious balancing act. You're constantly making trade-offs between how complex your AI model is, how much power it's sucking up, and how reliable it is. It's a really major engineering challenge.
And the control systems themselves are getting a whole lot smarter. We're moving to these advanced methods that are specifically designed to handle unexpected disturbances, complex interactions, and just plain unpredictable behavior, stuff that would totally confuse traditional systems. These are basically the factory's advanced motor skills.
So we've built a factory that can see, predict, and react. But in a world where literally everything is connected, this creates a brand new vulnerability. So the final piece of this puzzle is protection. We have to build a digital fortress around this incredibly intelligent system.
If prediction is the brain and control is the reflexes, then cybersecurity, well, that's the factory's immune system. It's always on guard, constantly detecting threats, figuring out friend from foe, and neutralizing anything that could possibly harm the organism.
And this immune response has multiple layers. It starts with international standards, which are kind of like basic hygiene rules. Then you have network segmentation, which is like compartmentalizing the body so an infection in one area can't spread everywhere else. And finally, you have advanced AI techniques that are actively hunting for anomalies and preventing system overloads.
And this is where it gets incredibly powerful. New methods out there don't just tell you that something is wrong, they can tell you exactly where. They can pinpoint a digital anomaly and trace it all the way back to a specific valve, motor, or sensor out there on the factory floor. It's the ultimate connection between the digital and the physical worlds.
So let's just recap the journey we've been on here. We started in the past with these reactive systems built on fault trees. We moved into the present, this world of powerful predictive abilities thanks to AI, and we're now heading toward a future that is truly autonomous, driven by edge intelligence and advanced control.
In essence, we've watched the factory evolve from a simple machine into a complex, intelligent organism. It has a nervous system to react, a brain to predict, reflexes to act, and an immune system to protect itself. It's become a true predictive factory.
And that leaves us with one final fascinating question. As these systems get more and more intelligent, more autonomous, and more capable of running and protecting themselves, what does that mean for us? Where does human creativity, intuition, and ingenuity fit into the factory of tomorrow? That's the next chapter, and it's still being written.